सर स्टार्ट कर देते हैं हम, जो आएगा आता रहेगा, है ना। अच्छा अच्छा। क्यों, वेब ऑप्टिक्स भी कुछ करवाना है क्या आज? नहीं नहीं, वेब ऑप्टिक्स, वेब ऑप्टिक्स, वेब ऑप्टिक्स, वेब ऑप्टिक्स पूरा हो गया था। हाँ तब तो छोटा चैप्टर है, हो जाएगा सही है। हाँ ठीक है ठीक है ठीक है ठीक है, ओके ओके।
अंदर आ सकते हैं।
हाँ जी हाँ
नमस्कार।
जी, नमस्कार
गुड मॉर्निंग सर।
नमस्कार, गुड मॉर्निंग।
सभी
धन्यवाद, यू डिड ए वंडरफुल जॉब। कुछ दिक्कत तो नहीं थी कल?
नहीं सर, अब
सब ठीक था
जी।
सब जगह?
हाँ सर, बस मेरी ही रूम में दिक्कत हुई थी, पानी चला गया था बाद में, वो खुला नहीं था, तो शायद वो काफ़ी दिनों से नहीं खुला था।
अब तो खुल गया?
अब मैंने खोला था सुबह।
बंद होगा होगा
जी बंद ही होगा, वो पता नहीं।
अच्छा वो नीचे से बंद होगा सर।
हाँ जी
आप
जी।
उनको फ़ोन करो, क्या नाम से, ताराचंद जी को।
नहीं हमने नहीं, आज खुल दिया सर।
अच्छा,
आप
इतने दिन से
अगर
कैसे काम चल रहा था आपका?
मैं तो सर कम ही यूज़ करता हूँ पानी का, तो
गुड मॉर्निंग सर।
लिमिटेशन ही।
सर का पहले से बंद था शायद ये
जी
लगा।
जी। बोलिए।
नीचे का खेती में जा रहा होगा ना वो।
अभी हो सकता है सर, पहले तो मैं
नीचे
वही
2
डाउट किया
बीघे
था।
खेती है।
हाँ जी
नीचे खेती है बहुत सारी, पता है आपको?
जी।
आप खाली निकाल के ले लो। मैं पहले वही डाउट किया था ना सर, फिर बाद में सोचा हो सकता है दूसरा कुछ होगा।
हो गया था सर उनका।
हाँ हाँ हो गया।
अच्छा।
शर्मा जी थोड़ा समय पे, समय पे।
समझ में जाऊँगा।
हाँ नहीं आपको नहीं, सबको।
सबको ही नहीं, बच्चा वहाँ से नहीं निकला था सर, इसलिए गया हम लोग।
कहाँ से नहीं निकला? आपके रहते हुए बच्चा नहीं निकलेगा तो कब निकलेगा?
सर कोई कोई है मॉडल सर,
हैं?
कोई कोई चला है।
ऐसे मॉडल को पाल के क्यों रखा है आपने?
एक दिन तो आया था और सही टाइमिंग।
चेला भी कह रहे हो आप, उसको मॉडल भी कह रहे हो, कैसे काम चलेगा?
Okay, good morning, dear students. Yesterday, our topic was wave optics, no? So I think you got a little bit idea about wave optics. And in related with that, another topic that is also very short topic. Uh, Only few topics you have to read from there. And after that, the name of the chapter, chapter 11, that is dual nature of radiation and matter, dual nature of matter and radiation. So this chapter we're going to start today. So whenever we're going to start any chapter, first of all, we go towards the history of that development of physics. So wave optics, already you have seen that some problem arises in ray optics, and that problem can be solved with the help of wave optics. Again, scientists have been found that some problems are wave optics also, because the wave optics can explain some phenomena in the that is which cannot be explained by ray optics. Again, wave optics cannot explain some phenomena which can be explained with the help of dual nature of matter and radiation. So that's why development is continued. No, in the 18th, 19th century, the development of physics has been continued till 20th century. So today our topic is dual nature of matter and radiation. So dual means two. Nature, all of you know that dual nature, that is characteristics, two nature, two characteristics. Matter, yeah, through the medium, particles concerned, and radiation means light. So light can show dual nature. Regarding that, we have to discuss. So today our uh, topic, dual nature of matter and radiation. For that, the development of physics is that some phenomena like photoelectric effect, Compton effect, or Raman effect, which cannot be explained with the help of wave optics, that can be explained with the help of the dual nature of matter and radiation. All right. So ray optics cannot be explained. Some topics like interference, diffraction, that can be explained with the help of wave optics. Again, wave optics cannot explain some phenomena like Compton effect, photoelectric effect, which can be explained with the help of dual nature of matter and radiation. So let us start this chapter with your some screen. You try to observe that screen. I will share some screen with you, and step by step I'll analyze through complete chapter. And after the end of the chapter, again half an hour we will take for analysis of the question paper that used to come in the previous year of CBSE exam. Okay, so let us share the screen. Just a minute.
अटेंडेंस के बाद में बच्चों को वापस नहीं भेजना है। वो बच्चा गया है अभी, कौन सी क्लास का है?
वो तो 10th भी कर दो।
Okay, students. The name of the chapter is students. You are audible. Students, have you seen the screen? Dual nature of radiation and matter. Please say that means you are audible, students. Hello. Students, am I audible? Anil sir. Just a minute. Okay, today our chapter, that is chapter 11, dual nature of radiation and matter. The dual nature of radiation matter, what we going to read. First, you see the syllabus. That is introduction part. Then number 2, electron emission. Then photoelectric emission, experimental study of photoelectric effect, loss of photoelectric effect, effect of intensity, frequency, potential on photoelectric current, and their graphical representation. Einstein photoelectric equation, definition of work function, threshold frequency, stopping potential, and matter waves, that is de Broglie matter wave. So students, you see, mainly there are so many topics are there in the chapter, but main topics is that what is the graphical representation of effect of intensity and effect of frequency on photoelectric current. So if we go through this introduction part once again, introduction part means introduction part, whenever we going to observe, then we can say that the photoelectric emission, how it will be comes through with the help of dual nature of matter and radiation. So dual nature of radiation and matter, some introduction part is see the phenomena like interference, diffraction, polarization, which can be explained by wave nature of electromagnetic radiation. But the phenomena like photoelectric effect, Compton effect can be explained only by particle nature of electromagnetic radiation. Hence, depending on the interaction of electromagnetic radiation, exhibit dual nature, that is, they behave either wave or particles. All right. That means dual nature of radiation and matter. Why the importance we can take from the chapter? Because this chapter gives the idea of new topic, that is photoelectric effect and Compton effect, which cannot be explained with the help of wave optics. So let us see what is actually happened in case of photoelectric effect. So students, you see, there are different types of emission are there for electron how emitted from the metal surface. So number one, we can say electron can emit whenever metal becomes heated, that is called thermonic emission. Again, electrons can emit from the metal surface whenever high voltage we can apply. Suppose 10 to the power 8 volt per meter whenever applied across the circuit, then also from the cathode that electrons can emit it. Again, another one, secondary emission is there, that is fast moving electrons whenever strike on a metal surface, they transfer some of their energy to free electrons and electrons emit. And finally, another one, that is photoelectric effect, which is electromagnetic radiation of suitable energy or frequency are incident on the certain metal surface, then electrons are emitted from the metal surface. Those electrons are known as photoelectrons, which can produce a current that is called photoelectric current, and the effect is called photoelectric effect. So these are the four processes of electron emission from the metal surface. Once again, first one is the thermonic emission. Thermonic emission, you know, that means when metal becomes heated, then electrons are emitted. Second one is the field emission. Field emission means whenever electric field is applied 10 to the power 8 volt per meter, then also electron comes out. And third one is the secondary emission. Secondary emission means when fast moving electrons strike a metal surface, they transfer some of their energy to free electrons and electrons can come out. And fourth one, photoelectric effect. Photoelectric effect, for photoelectric effect, certain radiations like electromagnetic radiations, ultraviolet rays, whenever they having suitable energy and frequency, they are incident on the metal surface, then also electron comes out. That electrons are known as photoelectron, and the effect is called photoelectric effect, and the current is called photoelectric current. So these are the different processes for electron emission. Next, that photon. The idea of photon also necessary here. That what is photon? You see, whenever light interacts with matter, then you can say that light interacts with matter, that bundle of a packet of energy that is associated with it, that is called photon. Then packet of energy or bundle of energy associated with light, that is called photon. Or number of photon can be represented as the number of photon. Whenever more, we can say that light becomes more intense. That means intensity of light is more whenever number of photon is more. Then what is the energy of the photon? Energy can be expressed E equal to Planck constant multiplied by frequency. If energy equal to h nu, then energy, we can say that energy equal to hc by lambda, where h is the Planck constant and nu value equal to c by lambda. C is the speed of light and lambda is the wavelength. So photon energy, nothing but E equal to h nu. And what is photon? The bundle of energy whenever light interacts with matter, that is called photon. The photon, whenever number of photon is more, then we can say that light having maximum intensity. So here it is already written in the screen. You can observe that h is the Planck constant, nu is the frequency, c is the speed of light. And all of you know that what is the speed of light in vacuum? That is 3 into 10 to the power 8 meter per second. And lambda is called the wavelength of light. Next, what then if a photon is light, then what are the properties related with photon? So let us see what are the properties. First of all, a photon travels with the speed of light, that is 3 into 10 to the power 8 meter per second. It is minus 8, it is some error is there, 10 to the power not minus 8, 3 into 10 to the power plus 8. Next, it has zero rest mass. That means whenever photon become rest, then mass is zero. Then photon cannot exist at rest. तो photon कभी rest condition में हो नहीं सकता. Next है the kinetic mass of a photon. We know that E equal to mc square. Then kinetic mass कितना होगा? E by c square. If it will be E by c square, then in terms of wavelength, hc lambda. Then the momentum of the photon is, we know that momentum equal to P equal to E divided by C. If P equal to E divided by C is the energy, C is the speed of light, then in terms of wavelength, E by C equal to H by lambda. And photon travels in a straight, photon travels with the speed of light, but it is straight line. That means that's linear propagation time. That energy of the photon depends upon frequency of the photon. So the energy of the photon does not change when photon travels from one medium to another medium. That what it can say, that energy of the photon does not change. Energy of the photon depends upon frequency. So energy of the photon does not change when photon travels with one medium to another medium. And the seventh number property you see, wavelength of the photon changes in different media. So velocity of photon is different in different media. After that, photon is electrically neutral. So what is the meaning of electrical neutral? That it is not deflected by electric and magnetic field. Number 9, we see photon may show diffraction under given conditions. Photons are not deviated by magnetic and electric field. That is in the 8 number properties. Photon is electrically neutral. So these are the properties of photon. Some properties you try to remember. The main property is that what are the energy associated with photon? That is equal to E equal to h nu. Energy of the photon E equal to h nu. H means Planck constant and nu means frequency of the photon. And what is the value of the Planck constant? That is 6.62 10 to the power minus 34 joule into second. So that value, if you not remember, also in the question paper, in the top side, first page of the question paper, it is already given. That is constant value H equal to 6.62 10 to the power minus 34 joule second. If you can remember, you can remember. If you cannot remember, then you can see from the question paper also, because some value, some charge of the electron, mass of the electron, mass of the proton, these are already supplied in the question paper.
इसने सब सीट
So this is one property of the photon.
नहीं बुला
Next, photoelectric effect, which is the main concern for today's topic. That is, dual nature of matter and radiation. Whenever you're going to explain, then photoelectric effect is quite important for you. So photo means nothing but photon. Electric, that means how photon can causes electric effect. So this phenomena we have to study. Photoelectric effect means how photoelectrons are emitted from the metal surface. What are the conditions for it? If you want to increase the current, what you will do? If you want to increase the energy of the electron, what you will do? So these all the point we can summarize in this topic, that is photoelectric effect. For that, development is there. First, Hertz, one scientist is there. He performed one experiment that is called Hertz experiment. Then Leonard performed one experiment. After that, Einstein also studied about it. That is called experimental study of photoelectric effect, and finally got the conclusions for it, that photoelectric effect really में होता क्या है. तो let us see what is photoelectric effect. यहाँ पर लिखा है, देखो, the phenomenon of emission of electrons from metal surfaces are exposed to light energy. Light energy means X-ray हो सकते हैं, gamma ray हो सकते हैं, ultraviolet ray हो सकते हैं, visible rays होते हैं. What is the spectrum of light? That spectrum of electromagnetic spectrum, that anything, anyone, whenever incident with suitable frequency, then electrons comes out from the metal surface. All right. Whenever electrons can come out from the metal surface, then electrons are called photoelectrons, and the effect is called photoelectric effect. So a definition सबको remember होना चाहिए. What is photoelectric effect? Simply, photoelectric effect means the effect which occurs due to certain radiations like X-ray, ultraviolet ray, visible light. Whenever falls on the metal surface, electron can come out. And whenever electron can come out, then it is observed that the current will be produced, and this effect is called photoelectric effect. The electrons emitted by this effect are called photoelectrons. The current constituted by photoelectrons is called photoelectric current. Next, one note is necessary. Non-metals also show photoelectric effects. Liquid gases also show this effect, but limited extent. Okay, some restrictions are there. Such type of, on the metal, ultraviolet radiations just falls on it, and electrons comes out. These electrons are called photoelectrons. So you see, ultraviolet radiations falls on the metal, that the electrons comes out. This is called photoelectrons, and the effect is called photoelectric effect. So, dear students, I think you know about, you can try to understand it, that electrons, how it can come out from the metal surface when ultraviolet radiations of certain frequency falls on the metals. Metals other than alkali metals, then also visible light, but observe that no photoelectrons. So metals, nahi hone se photoelectrons will not emit. Visible light cannot emit photoelectrons from other than alkali metals. Okay, there are some restrictions are there. If the metals other than alkali metals, then visible light cannot extract photoelectrons from the metal surface. So one point now you see, electrons are coming out from the metal surface, then how electrons can come out from the metal surface? Some energy should be supplied. This energy, the minimum energy, that minimum energy which is required to eject an electron from the metal surface, that is called work function. So what is work function? Work function is an important definition in this chapter. Work function denoted by W or phi naught. Work function means that the minimum energy required for an electron eject from the metal surface. So if you want to eject an electron from the metal surface, then we have to apply some energy. That minimum energy is called the work function, because you know that if electrons are not bound to the atoms, but they are attracted by this metal surface, because electrons whenever come free, then their positive ions are attracted from the metal surface. So whenever you extract the electron from the metal surface, some energy is required. That energy is called, this minimum energy is called work function. And the unit of work function is electron volt. The W equal to W, or phi naught, is the symbol of work function, and unit is electron volt, and 1 electron volt equal to 1.6 10 to the power minus 19 joule. Okay students, 1 electron volt कितना है? 1.6 10 to the power minus 19 joule. So if it is alkali metal, then photoelectrons can emit it with the help of visible light. Now, experimental setup of photoelectric effect, that is very important. Experimental setup at any cost you have to understand, because experimental setup is the main features of photoelectric effect. So you see, two it is very small current. Whatever the current produced by photoelectric effect, that is very small current. And this is key. This one K denoted for key, or this is your potential divider, act like a commutator. Positive terminal of the battery connected to the anode, and negative terminal connected to the cathode. Okay, students? So in the figure we observed that it is a evacuated bulb, where window is there. Through window, light can falls on the surface. That surface is cathode, and another anode is connected there. In between anode and cathode, one micrometer connected in series. That micrometer measures the photoelectric current. So whenever the setup we're going to complete, then another voltmeter is needed. That voltmeter measures the potential difference between the cathode and anode. Now what will happen? You see that here it is C for cathode, A for anode, and W is the quartz window. So now it is connected. The key becomes connected. When ultraviolet ray falls on it, then you see electrons comes out from the metal surface, and whenever electrons comes out from the metal surface, then as the positive terminal of the battery connected to the anode, then some current is developed. That current is called photoelectric current. That current is photoelectric current. So more and more photons falls on the metal surface. That means ultraviolet light that is falls on the metal surface. More and more number of electrons comes out. Whenever more and more number of electrons comes out, there's this small photoelectric current. So this is first condition. Experimental setup photoelectric effect. Diagram part में ज़्यादा कुछ भी नहीं है. एक evacuated bulb. It consists of two electrode, cathode and anode, and a window is there through which ultraviolet radiation can fall on the cathode. In between the cathode and anode, we observe that two devices is there. One is called micrometer, and another one is called voltmeter. Voltmeter measures potential difference between cathode and anode, and micrometer measures photoelectric current between cathode and anode. When key becomes connected, then we observe that as the anode having positive potential, that's what will happen, that electrons are attracted towards the anode, and whenever electrons are reach the plate, it can constitute a current. That current is called photoelectric current. And what is the name of the effect? That effect is called photoelectric effect. So whenever you will draw this evacuated bulb, window, cathode, anode, micrometer, voltmeter, potential divider or commutator, or battery. So with the help of commutator, what we can do? We can change the terminal of the battery. We make it positive towards anode. You make negative also towards anode. It is possible. All right. So first it is positive, then we get the current. That current is called photoelectric current. So this dot is the symbol of photoelectron. The glass transmits only visible or infrared light, but not ultraviolet light. Quartz transmit ultraviolet light. So what is the importance of quartz window? Because quartz window can transmit ultraviolet light. Ultraviolet light can easily come. So here it is written that when suitable radiation when false are attracted towards the positive anode, and hence photoelectric current constitute. Okay. So dear students, once again you see here it is already written that when light of suitable frequency, light may be ultraviolet light, maybe whatever may be the light, but here it is quartz window. Quartz window can through quartz window it can transmit ultraviolet light. So ultraviolet light having suitable frequency that falls on the metallic cathode, photoelectrons are emitted, and this electron constitute a current, that is photoelectric current, and the effect is called photoelectric effect. So this is your experimental setup. Okay. So experimental setup, you see what is going to happen. Now let's see that anode become positive electric current. If suppose anode become negative, what will happen? It will come towards the anode. If anode becomes negative potential, then what will happen? Electron will be repelled back. So gradually photoelectric current and towards the anode, then what will happen? That photoelectric current becomes zero. And whenever photoelectric current becomes zero, the potential which makes the photoelectric current become zero, that is called stopping potential. All right. The stopping potential is the negative potential which can cause no photoelectrons can come out from the metal surface. Photoelectric current is zero. So with the potential which can make the photoelectric current zero, that is called stopping potential. Stopping potential denoted by the letter capital V, V naught. V naught is the notation for stopping potential. As you know that potential denoted by V, but stopping potential denoted by V naught. So dear students, anything else from experimental setup of photoelectric effect? We can proceed next. Dear students, you understand photoelectric effect? Okay. Please respond, okay? Now we see photoelectric current we are constituting with the help of incident light whenever falls on the metal surface. Now, whenever incident light carry two characteristics, one is called intensity, another one is called frequency. Sometimes you can make the intensity constant, sometimes you can make the frequency constant. So different characteristics we can observe. 4 characteristics are needed by experimental study of photoelectric effect. What are the 4 characteristics is needed? First one is effect of intensity on photoelectric current. Second one, effect of frequency. Third one, that is effect of stopping potential. And fourth one is the effect of matter. Okay, these are the 4 graphical representation is necessary for photoelectric effect, complete study of photoelectric effect. So whenever you go through the photoelectric effect experimental study, then one by one you'll get some graph. That is, first one is the effect of intensity. So let us see what is the effect of intensity. Intensity, x-axis, y-axis current, then the graph becomes a straight line that passes through the origin. That means the intensity is more, that current becomes more. So whenever intensity becomes more, current becomes more, because intensity related with the number of photons. The number of photons, whenever maximum number of photons strike on the cathode, more and more electrons will be emitted, and whenever number of electrons are emitted, it can constitute photoelectric current. So current directly proportional with the intensity of light. But frequency remains constant whenever we increase the intensity. Okay. But how long it will be? The current become constant saturation current. That is called your saturation current. So for a fixed frequency, the photoelectric current increases linearly with the increase of intensity of incident light. So this graph we are observing here. After that, effect of potential on photoelectric current. So potential versus current का graph कैसा होगा देखो. It is also very important graph. एक हो गया this part. For L1 is the initial intensity and L2 is the final intensity. So initial intensity whenever less, then we observe that the current will be less than the next intensity L2, because L2 is more than L1. Intensity is more, current is more. And whenever it becomes a straight line for intensity L1, for intensity L2, then it is called saturation value of the current. Now, in this graph, we observe that the red line just intersect the 2 point of the intensity by green line. Now, suppose if you increase it, then it will just strike on the potential axis. In the textbook, it is given like that, but in this graph, it is not observing. So if you enlarge it and if you extend it back, then it will go through the reverse axis of the potential, and both the line will, and that point, you know what is that point? That is called stopping potential. That means stopping potential related with frequency, but current related with intensity. So intensity increase करने से students क्या होगा? Intensity whenever increases, then current will increases, because current is linearly increases with the intensity of light. Frequency remains constant here. That's why stopping potential is 0. Next. This current is saturation current, all right. So for a fixed frequency and intensity of incident light, the photoelectric current increases with the increase of positive potential applied to the anode. When all the photoelectrics reach to the plate, a current becomes maximum. That is called saturation current. So L1, whenever for L1 we got the saturation current, for L2 we got another saturation current. But whenever intensity versus current we will draw, then it becomes a straight line. So whenever it will be extended, it will just strike on the negative axis of potential. when potential is decreases, the current decreases but does not become zero. And potential when becomes zero? Whenever some negative potential is applied through it. So when potential is decreases, the current decreases, but does not become zero at zero potential. This shows even in the absence of oscillating potential, a few photoelectrons manage to reach the plate at their own due to their kinetic energy. Kinetic energy little bit is there, so due to that kinetic energy, some of the photoelectron reach. So you see, when negative potential is applied to the plate with respect to cathode, then photoelectric current becomes zero to a particular value of potential that is called stopping potential. So two important definitions we have got here. One is the work function, another one is the stopping potential. So energy required for an electron to eject from the metal surface called work function, that is denoted by phi naught or W. And cutoff potential or stopping potential is that with respect to cathode, then photoelectric current becomes zero. And whenever negative potential makes the photoelectric current zero, stopping potential, it is denoted by V naught. Okay, students, it is denoted by V naught. Intensity of incident light does not affect the stopping potential. तो इंटेंसिटी का साथ स्टॉपिंग पोटेंशियल का कोई मतलब नहीं है. इंटेंसिटी का साथ इसका रिलेशन है, इंटेंसिटी का साथ रिलेशन ऑफ इलेक्ट्रिक photoelectric current. Okay, so whenever intensity is more, photoelectric current is more. So whenever intensity is changing, but which remains constant, that stopping potential depends on what? Let us see. Stopping potential depends on what? So number 3, it is written that effect of incident light on effect of frequency of incident light on photoelectric current. तो frequency increase करने से photoelectric current का क्या होता है, ये अभी हम लोग observe करेंगे. What are the effect of frequency then photoelectric current? So here it is written, for a fixed intensity of incident light, the photoelectric current does not depend on the frequency of incident light. The photoelectric current never depends on frequency. It depends on, it simply depends on the number of photoelectrons that is emitted. In turn, the number of photon incident, not on the energy of photons. Okay. So for a fixed intensity, the photoelectric current does not depend on frequency, because the photoelectric current simply depends on the number of photoelectrons and in turn on the number of photons incident and not on the energy. Okay, students? तो frequency का साथ photoelectric current का कोई relation नहीं है. Frequency related with stopping potential or kinetic energy of the electron. The effect of frequency of incident light on stopping potential. तो frequency का साथ stopping potential का what kind of relation? Let us see. So now we draw a graph. That graph relate you stopping potential versus frequency, nu versus V naught. So x-axis, that is the potential, and plus sign right hand side and negative left hand side. That y-axis, that is current, photoelectric current, and this is the graph for one frequency, that is nu1. When one intersect on the potential axis, then negative potential Vs1. Another graph that you can observe for nu2, it is Vs2, where Vs2 is the another stopping potential. But you see, in both the cases, you can change nu1, you can change nu2, then stopping potential changes. But what is remain constant? The constant is in the graph becomes 1 point. If they match each other, both the graph you can see matched here, they will be coincide. So coinciding point shows that means photoelectric current remains same for both the frequency. But frequency can changes the stopping potential. More frequency, more stopping potential, less frequency, less stopping potential. Okay, student? So these graphs are very important. First one, effect of intensity, and now we are discussing effect of frequency. Intensity can change the current, but frequency can change the frequency, maximum energy of the photoelectron, because stopping potential measures the kinetic energy of the photoelectron. So in terms of that, we can say that kinetic energy half of mv maximum square equal to EV naught. This is the relation between stopping potential and kinetic energy. The effect of frequency on stopping potential. So here due to is greater than nu1, nu2 frequency is greater than nu1 frequency. So frequency whenever more, then stopping potential also more. Now you think about that frequency more, stopping potential more. Frequency less, stopping potential less. So if you draw the graph, how it will look like? Can you imagine? That means stopping potential more, frequency more. Stopping potential less, frequency less. So if we draw again another graph, stopping potential versus frequency, then also a characteristics will come out, and this is become a straight line, because less, less, more, more. That means we can say they are directly proportional to each other. But what quantity remains constant? That is your intensity. So that is saturation current. For a fixed intensity of incident light, the photoelectric current increases and is saturated with increases in positive potential applied to the anode. However, the saturation current is same for different frequency for the incident light. The saturation current never change whenever you change the frequency. When potential is decreases and taken below zero, the photoelectric current decreases to zero at different stopping potential for different frequencies. When potential is decreased, taken below zero, photoelectric current decreases to zero, but at different stopping potential for different frequencies. Higher frequency having higher stopping potential. That's why stopping potential is the measures of what? Stopping potential directly proportional to frequency. So here you see threshold frequency. What do you mean by threshold frequency? So threshold frequency also one characteristic below which photoelectric emission is not possible. The photoelectric emission के लिए क्या है? Threshold frequency one important factor. It only can cause photoelectric. So the metals have certain threshold frequencies there. If it is less than that frequency, no photoelectrons can emit. So photoelectrons emission होने के लिए incident frequency must be more than the threshold frequency. Okay, students? Now we are doing between frequency versus stopping potential. So frequency versus stopping potential is the straight line, and that straight line just strike on the frequency axis with a value that is called nu naught. And you can say that there is a gap from 0 to nu naught. No, in the graph it is observed that there is a gap between 0 to nu naught. What does it indicate? It indicates stopping potential directly proportional to the frequency of the incident radiation. Second point is that the graph intersect not at the origin, it will be little bit gap and after nu naught stopping potential increases. So the frequency which can cause photoelectric emission, more than that photoelectric emission is possible, otherwise not possible. That frequency is called threshold frequency. So threshold frequency is a characteristic of the material below which no photoelectric emission is possible. Say the graph between stopping potential and frequency does not pass through the origin. So it is observing, no? It shows that there is a minimum value of frequency called threshold frequency below which photoelectric emission is not possible. However, high the intensity of incident light may be. तो आप लोग जितना intensity change करो, but frequency less than threshold frequency, then no photoelectric emission is possible. It is possible when incident radiation having more threshold frequency, more frequency than threshold frequency. So it depends upon the nature of the metal. That means all the metals having different threshold frequencies. The nature of the metal emitting photoelectrons. Now, conclusions में हम लोग आएंगे. So once again, dear students, we have got introduction part that why photoelectric effect is necessary, why dual nature, idea of dual nature is necessary. So after this idea, we come across the experimental setup. Then we have got effect of intensity, effect of frequency on incident light. Intensity increase होने से हम लोग देखा that intensity can increase the photoelectric current. What will happen? Stopping potential is different, but intensity remains same. And we have got some graphs. So these graphs are very important graph. I hope all of you will try to draw it, try to understand it. And in the book, it is everything is given very in the clear way. You no need to go for any kind of reference book and other notes for this chapter, because this chapter, whatever it is written in the book, that is clear cut, visible, clear cut, can be understandable. So laws of photoelectric emission. What are the laws of photoelectric emission? First होगा law of intensity. Second one क्या होगा? Second one होगा that is your law of frequency. Third one effect of metal, and fourth one, I think there is no lag of time. Photoelectric emission is a instantaneous process. No, they not take a single second also to come out from the metal surface. Just light falls and the electron comes out. So first one, law of intensity, or whatever it is written, you should read this one, that for a given substance, there is a minimum value of frequency of incident light called threshold frequency below which no photoelectric emission is possible. However, the intensity of incident light may be. So photo emission होने के लिए क्या है? The number of photoelectrons emitted per second is directly proportional to the intensity of incident light. So this is called law of intensity. And provided the frequency above threshold frequency, so this is the one characteristic. Third one, the maximum kinetic energy of the photoelectron directly proportional to the frequency, provided the frequency above the threshold frequency. So maximum kinetic energy is the measures of stopping potential. The maximum kinetic energy of the photoelectron independent of the intensity of light. So this is always, no? Kinetic energy does not depend upon intensity, and photoelectric current does not depend upon frequency. Frequency का relation है stopping potential का साथ और energy of the electron, but intensity का relation है number of photons. Intensity relation है electric current, photoelectric current. This photoelectric emission is instantaneous. As soon as the photon of suitable frequency falls on the substance, it emits photoelectrons. तो इसको हम बोलते हैं no time lag. So first one is the first one is simple characteristics of photoelectric emission. Whenever there is a frequency of incident light more than the threshold frequency. Second one is called law of intensity. That intensity more, current more. There is no change of whatever the current. Third one, that is based on the frequency. Maximum kinetic energy is independent of the intensity of the incident light. And last one, no time lag. So these are the laws of photoelectric emission. It is also required. And photoelectric emission that will be suitable frequency is, that is always known, that means photoelectric emission के लिए suitable frequency is required. Now Einstein photoelectric equation. तो आफ्टर दैट फाइनल कंक्लूजन में आइंस्टाइन फोटोइलेक्ट्रिक इक्वेशन में आएंगे. तो आइंस्टाइन क्या बोला था फोटोइलेक्ट्रिक इक्वेशन के बारे में देखो. तो फोटोइलेक्ट्रिक एमिशन, यू नो दैट इलेक्ट्रॉन्स कम्स आउट फ्रॉम द मेटल सरफेस So Einstein photoelectric emission is nothing but little bit basic idea is given. So actually what going to happen in the metal surface. So Einstein used to say, when photon is incident on the metal surface, then first photon is absorbed by metal surface. Then complete energy of the photon divided into two parts. One part gives the work function. That means minimum energy to eject an electron from the metal surface. And another part gives that kinetic energy of the photoelectron. That means the energy of the photon, that means energy of the photon means h nu divided into two parts. First one we can say work function, second part we can say kinetic energy. That means h nu equal to phi naught plus half of mv maximum speed. When photon of energy h nu falls on a metal surface, the energy of the photon is absorbed by the electron is used in two ways. First one, a part of energy is used to overcome the surface barrier, come out from the metal surface. This one, second, the remaining velocity electron is equal to the velocity of electron, not like velocity of electron. So this second part gives the work function. So in this way, whenever in the formula we can say this formula becomes, suppose this is metal, photon strike and electron comes. This electron having that is phi equal to h nu, this work function, and electron whenever comes out it has function plus half of mv square. According to the law of conservation of energy, that h nu equal to phi plus half of mv maximum square. So this is called Einstein photoelectric equation. All right, student. So what is Einstein photoelectric equation? That energy of the photon phi equal to half of mv square, that is kinetic energy. So maximum energy electron can achieve by energy of the photon. After that, phi naught equal to h nu naught plus half mv square. So this is another part of Einstein photoelectric equation. So half of mv square equal to h can take common, nu minus nu naught. So this is called Einstein photoelectric emission. So what is Einstein photoelectric emission? Simply, when photons strike on the metal surface, then it can divide into two parts. First part gives the energy work function, and second part gives the energy of the photoelectrons. That's why it can be written as h nu equal to phi plus half of mv maximum square. And after rearranging the equation, kinetic energy of the electron equal to h nu minus nu naught. Now you see, if suppose nu naught is less than threshold frequency, if incident frequency is less than the threshold frequency, then what will happen? No photoelectrons can emit. So this one can be verified by Einstein. So this is another form. Half of mv square equal to h nu minus nu naught. One condition is that if nu is smaller than nu naught, half of mv square is negative, which is not possible. Therefore, photoelectric emission के लिए क्या होना चाहिए? Incident frequency must be greater than nu naught. Since one photon emits one electron, so number of photoelectrons per second is directly proportional to the intensity of incident light. एक फोटोन क्या करते हैं? एक ही इलेक्ट्रॉन को निकालते हैं. तो नंबर ऑफ फोटोन जितना आएगा इतना इलेक्ट्रॉन विल कम्स आउट. तो इलेक्ट्रॉन मोर एंड मोर कम्स आउट मींस photoelectron current increases. So photoelectric current increases with the number of photons. So directly proportional there. It is clear that half of mv square is proportional to frequency, as h and nu naught are constant. This shows that kinetic energy to photoelectron directly proportional to frequency. That is always. Photoelectric emission is due to collision between the photon and an electron. As such, there cannot be any significant time lag between the incident photon and emission of photoelectrons. That is, process is instantaneous. It is found that delay is not possible. Only 10 to the power minus 10 second. So 10 to the power minus 10 second में क्या होता है? फोन निकाल जाते हैं इलेक्ट्रॉन फ्रॉम द मेटल सरफेस. So these three definitions, all the students will read. Three definitions are important: work function, stopping potential, and threshold frequency. Okay, students? Work function, stopping potential, and the cutoff potential for threshold frequency. Work function means minimum energy of the incident radiation required to remove an electron from the metal surface. Stopping potential means जहां पर फोटोइलेक्ट्रिक करंट जीरो, जो पोटेंशियल नेगेटिव पोटेंशियल फोटोइलेक्ट्रिक करंट को जीरो करते हैं, द रिटार्डिंग इलेक्ट्रिक पोटेंशियल व्हिच कैन स्टॉप द एमिटेड इलेक्ट्रॉन्स और called stopping potential. Stopping potential is proportional to the kinetic energy. That's why kinetic energy equal to EV naught. Cutoff or threshold frequency, the minimum frequency of the incident radiation below which no photoelectric emission is possible. That is called cutoff or threshold frequency. It is independent of incident radiation. Okay. So these are the important definition from the chapter: work function, stopping potential, cutoff potential, or stopping potential, or cutoff frequency, or threshold frequency. All right. So three definitions we have to read. Next, final one is the dual nature of radiation and matter. Two nature of light: particle nature and wave nature. Wave theory of electromagnetic radiation explains the phenomena interference, diffraction, polarization. That is, initially I used to say you that wave theory can successfully explain the topic interference, diffraction, and polarization. But it cannot explain what? Compton effect, photoelectric effect. So you see, on the other hand, quantum theory, that whatever theory now you are reading, that is called quantum theory of electromagnetic radiation, that successfully explain photoelectric effect, Compton effect, black body radiation, X-ray spectra. So dear students, one question has come, I think in the year 2017 or 18 like that, that name one effect that can be explained with the help of quantum nature of light. So that is nothing but photoelectric effect. So related question, that means wave theory can explain interference, diffraction, polarization. Again, quantum theory of light can be explained photoelectric effect, Compton effect, and black body radiations. So what is wave dual nature of light? Let us see what is dual nature of light. Radiation having dual nature, wave nature and particle nature. Louis de Broglie suggested that particles mean very fundamental particles, light particles called electrons, protons, neutrons, have dual nature. That means whenever electrons passes through the matter, then a wave associated with it, right? So very simple line, but it means a lot. That means material particle in motion, a wave associated with it. If the material particle in motion, a wave associated with it, then some wavelength must be there. What is the wavelength? That is de Broglie given that lambda equal to h by p, where p is the momentum, h is the Planck constant, and that momentum equal to m into v. So in no experiment matter exists both particle as well as wave simultaneously. It is either one or the other aspect. The two aspects are complementary to each other. So some conditions can be applied. And his suggested was based on the nature loves symmetry. That means whatever the things going on, that is the fundamental is that the nature always loves symmetry. The universe made up of particles, radiations, and both entities must be symmetrical. If a particle can show, that means light can show particle nature, then it must show wave nature also, because the nature loves symmetry. So de Broglie wave, so material particle whenever in motion, such a wave associated with it, and the wavelength of the wave is lambda. According to de Broglie, a moving material particle can be associated with a wave, and wave can be guided the motion of the particle. The waves associated with the moving material particle are known as de Broglie waves or matter waves. expression of de Broglie waves. That is, according to quantum theory, the energy is h nu hc by lambda. According to Einstein theory, equal to mc square. So lambda equal to h by mc or lambda equal to h by p, where p is the momentum and m is the mass of the particle, c is the speed of light. If it will be electron, then m is the mass of the electron. So if instead of photon, we have a material particle of mass m, then material particle के लिए velocity क्या होगा? That will be v. Then this relation can changes to lambda equal to h by mv. Okay, students. So this is your de Broglie wave, de Broglie wavelength. All right, and for that work, he has got the Nobel Prize in the year 1935. So you see a simple line which means a lot, no? That all material particle in motion, a wave associated with it. That is the de Broglie wave, and that wavelength of the wave is lambda equal to h by mv, or simply lambda equal to h by p. So that is the end of this chapter. Now we will go towards the question bank. Some questions, very interesting question I have said for you. So let us see the questions one by one. That half an hour only for discussion of questions which are used to come in the previous pre-board exams or CBSE exams. Okay, students? So let us proceed that. So you remember about photoelectric effect or experimental study or that whatever definitions, only few topics. Okay. Question back now on to see. Okay, students, now we'll start the questions related to the dual nature of radiation and matter. No? First question. The stopping potential for photosensitive material is minus 5 volt. Then what is the work function for the material? Option A, plus 5 joule. Option B, minus 5 joule. Option C, plus 5 electron volt. Option D, minus 0.5 electron volt. Anyone can say? What is your answer for that question? Number 1, stopping potential is minus 5 volt. Then what is the work function? The answer should be plus 5 electron volt. So you can note it down. The stopping potential minus, then that value will be plus. If it will be minus 6 volt, then it will be minus 6 joule or 6 electron volt. Next, the stopping potential for threshold frequency for a given certain material is related as directly proportional to each other, inversely proportional to each other, equal to each other. There is no such relation between stopping potential and threshold frequency. So what is your answer? Expectation, that should be A, no? Directly proportional to each other. Okay. Then third equation is that what is the momentum of the photon? Momentum of the photon means we have got that lambda equal to h by p. So p whenever go in the left hand side, then momentum of the photon becomes h by lambda. The first option is the answer for that question, no? Next, two charged particles A and B of masses Ma, Mb. Ma is greater than Mb, move with same kinetic energy. Then de Broglie wavelength for the two particles would be given by which one? That we remember that mass is inversely proportional to wavelength. So if Ma is more, that means lambda A is less, lambda B is more. So lambda B option is the correct one. Okay? So B option is the correct one for that. Next one, the quantum nature of light explains the observation on photoelectric effect as there is a minimum incident radiation below which no electrons are emitted. The maximum kinetic energy of the photoelectron depends on the frequency of incident radiation. On metal surfaces, is illuminated, the electrons are ejected from the surface and the material after some time. The photoelectric current is independent of the intensity of incident radiation. So, which one? Quantum nature of light explain that maximum current energy of the photoelectron depends only on the frequency of incident radiation, or there is a minimum frequency of incident radiation. So, for question number 5, let us see the answer. There is a minimum frequency of incident radiation below which no electrons are emitted. That already I have explained. No threshold frequency, minimum frequency is needed. So, this question, this is, you see, study the following graph. You observing the graph. There is potential, number 1 potential, and the x-axis, and in the y-axis photoelectric current. We have got the graph that intersect in the potential axis, that is called stopping potential, and whatever on the right hand side of that graph, xy axis, that is two graphs are matching and A and B are different. So which one is the correct option? FA, frequency of A and frequency of B are not equal, that is correct, or frequency of B and frequency of C are equal. So which one is your correct answer? That you have to search out. So you see, option C, FA equal to FB. That means frequency of A, frequency of B are equal. Why? Because stopping potential for that are equal. So as the stopping potential is the frequency directly proportional to stopping potential, so A and B frequency are equal. The option C, and photoelectric current between A and C are different. So A or C are different. So that's why C is the correct option. We can move. So these are the answer of all that question. Okay. The first one 5 electron volts, second one directly proportional to each other, third one H by lambda, fourth one lambda is smaller than lambda B, fifth one A, sixth C. Next, ascertain region-based question. Ascertain the number of photoelectrons are emitted by photosensitive material depends on the intensity of light falling which on the surface of material. Region, the intensity of light falling is independent of the nature of material. So, which option is the correct option? A, B, C, D. The number of photoelectrons emitted by photosensitive material depend on intensity of light, that is true. And number 2, intensity of light falling is independent of the nature of the material, that is also true. So both are the options are true. If both the options are true, then we can say that R is the correct explanation of A, and that's why our ascertain region-based answer is option A. Both are correct, and R is the correct explanation of A. Second one, when proton and alpha particle are accelerated by similar potential difference, the wavelength for proton is greater than the alpha particle. That is always because proton less mass when compared to alpha particle. That's why wavelength of proton is more. Wavelength of the waves inversely proportional to the square root of the product of their masses and charges. That is the Broglie wavelength for an electron for a charge we have got, and that's why this is true. So both the options are true, and R is the correct explanation of A. That's why answer is A. Next, photoelectric number 3. Photoelectric current demonstrates the particle nature of light. Is it true? Photoelectric current, no particle nature. They explain both. No particle nature also, wave nature also, dual nature. The number of photons emitted depends upon the intensity of light falling on the given. This is true. So A is false, ascertain is false, region is true. The option is D. Option is B. Photoelectric current demonstrate the particle nature of light. No, option should be D. Okay. So here it is wrong. Print the photoelectric current demonstrate both particle nature and wave nature. Next, a proton and alpha particle are accelerated by the same potential difference. Which of them will possess higher de Broglie wavelength and less kinetic energy? Justify your answer. So whenever such type of two particles are there, we're going to compare proton and alpha particle. You have to compare their masses. Proton mass is more or alpha particle mass is more. The proton mass is less than the alpha particle. So higher the Broglie wavelength for proton, लेस काइनेटिक एनर्जी. अगेन काइनेटिक एनर्जी के लिए हम लोग क्या करेंगे? दैट मीन्स काइनेटिक एनर्जी डायरेक्टली प्रोपोर्शनल टू द चार्ज. तो अल्फा पार्टिकल का काइनेटिक एनर्जी ज्यादा होगा विद कंपेयर टू प्रोटॉन. तो दिस इज योर आंसर. फर्स्ट वन, wavelength is more for proton because lambda is inversely proportional to the square root of mass, and this mass is more for less for proton, and that's why wavelength is more. Again, proton having less kinetic energy because that's why less kinetic energy for proton, and alpha particle having more kinetic energy. Next, a beam of monochromatic radiation is incident on the photosensitive surface. Answer the following question. First one, do the emitted photoelectrons have same kinetic energy? Emitted photoelectrons having same kinetic energy? Does kinetic energy of the electron emitted depend on intensity of incident radiation? Or number 3, on what factors the number of photoelectrons emitted depends on? So these are the points already discussed, no? That photoelectrons, photoelectric current depends on what factors already we have discussed. So answer will make, we can say that. First one, no, all the electrons are bound to the different layers of the metal. So more tightly bound electrons come out with less kinetic energy, no? Electrons having not same kinetic energy, all the energies are different. Number 2, no, number 2 also no, kinetic energy of the electron does not depend upon the intensity. Kinetic energy depends upon frequency. That should be greater than the threshold frequency of the incident radiation. And number 3, you know, that intensity of light is more means, that means the electron can having more and more number of electrons can comes out, that whose energy will be greater than the work function of the material. So these are the 3 parts. So once again, you see the very important question. Emitted photoelectrons have same kinetic energy? No. Why no? Because electrons are staying at different layers, so all the electrons number comes out, then different kinetic energy. Does the kinetic energy of the photoelectron intensity of it depends on intensity? No. Or where it depends on frequency. And number 3, on what factor does the number of photoelectrons emitted depend upon? It depends upon intensity of the incident light. Next, such type of equation used to come, more and more numbers of questions used to come from this type only. That a proton and electron having same velocity, which one having higher de Broglie wavelength. So you know that electron mass is less, so de Broglie wavelength for electron will be more. A proton and alpha particle are oscillated through the same potential, which one of the two has greater value of de Broglie wavelength associated with it, less kinetic energy. Already we have discussed this question, so you can say like that way, okay? Then lambda equal to 1 by root over mq. So lambda p is more than lambda alpha, and k is kinetic energy proportional to charge. So kp is less than k alpha. K is the kinetic energy. So these are different types of questions for you. You can observe it that only few relation, if you remember from the chapter, you can go through it and can achieve the full marks from this chapter. No, students? So simple chapter. If only few topics if you read, then only you can achieve the good marks from this chapter. All right. So once again from the beginning, I want to say you, that means how you will read the chapter, just overview, you try to listen. First of all, dual nature of radiation and matter, whenever you're going to start, you read the definition. Definition means work function. After that, you will read the definition of that is cutoff potential or stopping potential, and you will read what is threshold frequency. Okay, definition of that. Then you go through, that means experimental study of photoelectric effect. Whenever you go through the experimental study of photoelectric effect, then more and more idea you will get that how intensity related with the photoelectric current, how frequency related with the kinetic energy, whatever their graphical representation, and how stopping potential related with different metals. So 4 graphs you have to study. Then you go through the idea of photon. Photon is what? What is the energy of the photon? Then energy of the photon, and photon, what are the properties of photon? Then Einstein photoelectric equation and loss of photoelectric emission. So these are the points you have to read. And finally, what is the de Broglie wavelength associated with material particle? That fundamental thing, that dual nature of matter can explain some phenomena. This phenomena cannot be explained with the help of wave optics. So in this way, you can sum up this chapter. And after that, you go through some certain region-based question, you go through some MCQ question, you go through 2 or 3 numericals from different corners. Very short chapter, 3-4 marks easily you can obtain from these topics on. Okay, students? So now I have to conclude the chapter. Wish you all the best for the forthcoming final examination. I hope that all of you can come out with flying colors. Just to practice by writing everything. Okay, thank you one and all.